How's it going, guys? Today we're going to be going over a problem called same tree, and this is a question that's being asked by Google right now. Alright guys, so today our problem is called same tree. It's a question from Google. I've recently got a lot of requests for tree problems, so that's what we're going to be doing today. As a quick reminder, if you guys want to have input on what kinds of questions I'm solving and why, you guys can check the link in the description and join my Patreon to try and do so. So our problem description today says, given two binary trees, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So in example 1 here, our input is two trees. So 1, 2, 3, 1, 2, 3, and we would return true because these trees both are structurally identical and they contain the same values. So now just as a quick example that is not structurally identical, because I think that's the thing that's not as clear, we have example 2 here, and so we have a 1 and then as a left child a 2, and then our second tree has a 1 as the root as well, but it has a 2 as the right child, so therefore it's not structurally identical. So as it is the case with a lot of tree problems, this is going to be a recursive problem. Just as a reminder, you guys could solve this iteratively. I just think it makes a lot of sense to do recursively. The code normally is shorter and it's a lot easier to understand. One way that kind of recursion falls apart is that for really, really large trees, you could run into a Stack Overflow, but we're not really going to worry about that in this case. This code will actually pass the test cases, hopefully, and we'll be fine. But anyways, so with recursive solutions, I try and stress to people to think about the base case, right? So again, we talked about it in one of our previous videos, but in recursive solutions, you guys always need one, a base case, and two, recursive calls, or one or multiple, to continue a recursion. So try and think about the simplest case, right? So if we're just comparing two trees here, what do we need to check? Well, we need to check that we have something to begin with, right? And so something like our base case will be, are these two trees null? And if they are null, then we're just going to say they're unique, right? If this is null and this is null, they're the same, therefore we have the same tree. Okay, so let's say that's not the case, right? That will be our base case, but let's say we're not in that case right now. Well, if we're not in that case, what are the other cases we can have? Well, we could have one thing here and nothing here, or we could have nothing here and one thing here. And so if that's either of those cases happen, right, that can't be the same tree. If I have the number 5 here and then the null here, or vice versa, null here, or no, 5 here and null here, they can't possibly be the same tree, right? They don't match up, they don't align, therefore they can't be the same tree. So that's something else we're going to check. Now let's say we're in a case where we have two objects, right? We have two nodes, they both have some sort of value. Now we just need to check their value, right? This is 5 and this is 7, they're not the same tree. But if this is 3 and this is 3, they are the same tree. So that's our three cases so far, right? So we have, if they're both null, we're going to return true because it's the same tree. If one of them is null, after our check for both of them being null, they can't be the same tree. Otherwise, if we have two valid roots and they don't have the same value, they can't be the same tree as well. And now we just need to get into our recursive call, which is basically going to say, okay, if none of those have triggered, now we just need to check, okay, are the left subtree of both of that node the same, and are the right subtrees of those nodes the same? And if they are, we'll return true, and if they are not, we'll return false. So I just tried to outline our code a little bit. Hopefully that made sense, and if it didn't, let's jump into the code now, and hopefully it'll make more sense once it's actually written. But so let's just go through those cases, right? So we said if P is null and Q is null, then we're just going to return true, right? Because if we have two things that are null, we're going to assume that those are identical trees because they're both the same. Now, else if one of them is null, right? So if P is null or Q is equal to null, whoops, then we're going to return false, right? Because if we have null here and something that's not null here, or something that's not null here and null here, they can't be the same. So we return false. Else if, now we definitely have two nodes, right, that are valid, because neither of these cases tripped, right? So we don't have them both being null, and not a single one of them is null. So now we have two nodes definitively, and now we just want to check their values, right? So this is a problem if they're not the same. So if p.val is not equal to q.val, then we can return false as well, right? Because if 3 doesn't equal 5, then we have a problem. Now this is just our recursive case finally, right? So if we haven't tripped any of these conditionals, we just want to check, okay, we have to be in the case where these two nodes have values and they're the same. So now we just need to verify that this current node's left subtree is the same and its right subtree is the same. So we'll just simply return is same tree of p.left, q.left, which will be comparing the left subtree of those two trees, and is same tree of p.right and q.right. And so if those things both come back as true, we'll say it's the same tree. And if they come back as one being true, one being false, we'll say that they're not the same tree. So I believe that this code works. Let's make sure that it does. Awesome, and it does. So as the runtime, I know I'm mentioning runtime for like the first time in forever in a video, but we're going to traverse the entire tree of P and the entire tree of Q. They have to have the same amount of nodes, right? Because otherwise they wouldn't possibly be the same tree. So I would say that the runtime here is like 2 of n, where n is just the number of nodes that we have in our tree. In big O notation, we would just say that's O of n. So guys, that's the runtime, big O of n. If you guys have any questions or anything I could do to help you guys, be sure to leave it in the comments below. You also, are free to let me know what kinds of questions you guys want to see in the comments. I'd love to hear it. If this was helpful, be sure to leave this video a like and subscribe to the channel for more. And I'll see you guys next time.